For years, the electric vehicle industry has been caught in an intense race centered around batteries, charging networks, and massive billion-dollar ambitions. But just when competitors believed they understood where the future was heading, Elon Musk introduced something that could completely reshape the industry overnight. The new technology reportedly pushes beyond 20,000 revolutions per minute and achieves one of the lowest drag coefficients ever recorded in a production car. This is not just another flashy announcement or routine upgrade. Industry insiders are already describing it as a breakthrough powerful enough to redefine transportation, shake up the competition, and leave major automakers struggling to keep up. So, what exactly is this mysterious new engine, and why are experts calling it a possible turning point in the EV battle? For more than a decade, the world's biggest automotive companies have been competing fiercely to dominate the future of transportation. The rise of electric vehicles did far more than introduce a new type of car. It completely transformed the direction of the global auto industry. Almost overnight, manufacturers realized that gasoline-powered vehicles were slowly becoming outdated, while one company appeared to be leading the transition into the future: Tesla. At first, many people doubted Tesla could stay ahead for long. The company seemed bold, innovative, and exciting, but also relatively small compared to established giants like Ford, General Motors, Toyota, and Volkswagen. These companies had decades of experience, enormous factories, advanced engineering capabilities, and global production networks already in place. Because of this, many analysts believed it was only a matter of time before traditional automakers caught up and overtook Tesla. That belief sparked one of the biggest technology races the automotive industry had ever seen. Billions of dollars poured into electric vehicle development. Companies hired huge teams of engineers and designers to create the next generation of EVs. Massive battery plants began appearing across multiple countries, while governments introduced incentives and environmental policies encouraging drivers to move away from gasoline vehicles. At the same time, new EV startups seemed to emerge constantly, each claiming to have technology capable of challenging Tesla's dominance. Investors became fascinated with electric mobility, and even companies with little automotive experience attracted enormous funding simply because they promised an electric future. For a while, it genuinely seemed possible that Tesla's lead might disappear. And to be fair, the competition improved quickly. Electric vehicles became more stylish, more dependable, and more practical for everyday driving. Battery technology advanced faster than expected, while charging infrastructure expanded rapidly across cities, highways, and shopping centers. Gradually, the rest of the industry appeared to be narrowing the gap. Some experts even predicted Tesla's advantage would eventually disappear entirely. Then Tesla revealed something unexpected. It wasn't just another vehicle design, a larger battery, or upgraded software. It was a completely new motor technology, and according to engineers who studied it, this was no ordinary motor. Reports suggest that many experts quickly realized Tesla had moved far beyond where most competitors currently stand. The most concerning part for rival automakers was not only the motor's performance and efficiency, but also how incredibly difficult it would be to replicate. Some industry experts quietly admitted that recreating this level of technology could take years, possibly close to a decade. By the time competitors finally catch up, Tesla may have already advanced even further. Suddenly, the EV race no longer looked evenly matched. What once felt like a competitive battle now began to resemble the early stages of complete market domination. Before this breakthrough, the electric vehicle market was already extremely competitive. Automakers around the world were fighting aggressively for market share, technological leadership, and consumer attention. Tesla itself also faced serious pressure during this period. One major example was the Tesla Cybertruck. For years, it was promoted as the future of transportation. When Elon Musk first unveiled the bold stainless steel pickup truck, It immediately captured global attention and became one of the most talked-about vehicle launches in recent history. The Cybertruck's sharp edges, futuristic styling, and promises of extraordinary performance made it look more like something out of a science fiction film than a traditional pickup truck. Millions of people watched its unveiling, and excitement spread rapidly across social media as fans and investors predicted it would revolutionize the truck market. However, the reality surrounding the Cybertruck has become much more complicated over time. Despite years of marketing and massive public anticipation, sales have reportedly fallen well below expectations. What was once promoted as a groundbreaking innovation in the EV industry is now facing challenges in attracting large numbers of everyday buyers. Although the Cybertruck still draws attention wherever it goes, public curiosity alone has not translated into the level of demand Tesla likely expected. Some reports even suggested that a noticeable portion of Cybertruck registrations came from companies connected to Elon Musk himself. Businesses such as SpaceX, XAI, and other Musk-related ventures were reportedly responsible for a significant share of registrations during one quarter. Analysts reviewing the numbers claimed that nearly 1 in 5 registered Cybertrucks during that period may have gone to Musk-linked organizations rather than independent customers. Without those internal purchases, the sales figures may have appeared even weaker. The Cybertruck's struggles also reflect the much larger battle happening across the electric vehicle industry today. When Tesla first rose to prominence, it stood far ahead of most competitors. Now, nearly every major automaker is aggressively developing electric vehicles. Consumers have more choices than ever before, along with lower prices and a wider range of designs. As competition intensifies, standing out in the EV market has become far more difficult. At the same time, the Cybertruck itself has deeply divided public opinion. Some people admire its bold and unconventional appearance, while others view it as impractical or too unusual for daily driving. Its high price has also discouraged many potential buyers, especially during a time when consumers are becoming more cautious about spending. In addition, reports involving recalls and quality concerns have raised doubts about the vehicle's reliability and long-term value. Even with these challenges, Elon Musk does not appear to be slowing down. Instead of focusing only on vehicle sales, he continues pushing Tesla toward ambitious technologies involving artificial intelligence, robotics, and self-driving robotaxi systems. This shift suggests Tesla may now see its future less as a traditional car manufacturer and more as a technology and AI-driven company. The Cybertruck was once expected to dominate roads and redefine the future of pickup trucks. Instead, it has become one of the clearest examples of how hype, innovation, and reality do not always move in the same direction. But Tesla's latest technological breakthrough may be generating even bigger reactions across the EV world. So, what exactly is this new technology, and why is it sending shockwaves through the electric vehicle industry? To understand why Tesla's new motor technology has captured so much attention, it's important to first understand one of the biggest challenges in electric vehicle engineering: the limits imposed by physics. For years, automakers around the world believed they were stuck with a difficult compromise. An electric vehicle could either deliver incredible speed and power or provide excellent efficiency and long driving range on a single charge. Achieving both at the same time seemed nearly impossible. High-performance electric vehicles often became extremely heavy, generated excessive heat, consumed large amounts of energy, and required complex cooling systems to operate safely. Meanwhile, vehicles designed mainly for efficiency usually felt less exciting and lacked the fast acceleration many drivers wanted. Over time, this trade-off became widely accepted throughout the automotive industry as an unavoidable limitation. Most manufacturers believed physics had already defined the boundaries of what electric vehicles could achieve. Tesla, however, refused to accept those limits. Rather than following the traditional approach, Tesla's engineers searched for an entirely different solution. After years of research and experimentation, they developed what many consider one of the most advanced electric motor designs ever used in a consumer vehicle. At the center of this breakthrough is a concept that sounds surprisingly simple in theory, yet is incredibly difficult to perfect: a carbon fiber-wrapped rotor. Inside every electric motor is a spinning component known as the rotor. When the motor operates, the rotor spins at incredibly high speeds. As those speeds increase, the forces inside the motor become extreme. In simple terms, the faster the rotor spins, the more pressure the motor experiences, almost as if it's trying to pull itself apart from the inside. Most traditional motors struggle to handle that level of stress safely. Tesla found a solution by wrapping the rotor in carbon fiber, a material known for being both extremely strong and remarkably lightweight. This carbon fiber layer works like protective armor, helping hold the rotor together even under enormous pressure. The results were remarkable. Tesla developed a motor capable of spinning at more than 20,000 revolutions per minute, a speed rarely seen in regular passenger vehicles. Performance levels like that were typically associated with specialized industrial equipment, not luxury sedans designed for daily driving. But the real breakthrough was not just the speed itself. What truly made Tesla's motor revolutionary was the level of control and stability it maintained at those extreme RPMs. The carbon fiber wrapping reduced vibrations and helped keep the rotor balanced and stable during operation. That stability improved the motor's magnetic efficiency, allowing more electrical energy to be converted into motion instead of being lost as heat. This advancement dramatically changed expectations for electric vehicles. The motor delivered instant torque and extraordinary acceleration while still remaining highly efficient during long-distance driving. It also stayed compact and lightweight, requiring less cooling than many competing systems. Most importantly, it achieved performance levels that many experts once believed were impossible in a practical everyday vehicle. The world saw the full potential of this technology in the Tesla Model S Plaid. The car stunned the automotive industry by accelerating from 0 to 60 miles per hour in under 2 seconds, outperforming many exotic hypercars worth millions of dollars. What made the achievement even more impressive was that the Model S Plaid remained a comfortable luxury sedan capable of carrying passengers over long distances. For decades, the automotive industry insisted drivers had to choose between speed and efficiency. Tesla demonstrated that both could exist in the same vehicle, and that changed the conversation around electric cars entirely. But Tesla's advantage goes far beyond performance alone. Many automotive companies know how to build eye-catching prototypes that generate excitement. They reveal futuristic concepts, attract investors, and dominate headlines for a while. However, history has repeatedly shown that creating a few impressive vehicles is very different from successfully manufacturing millions of them. That is where many companies struggle, and where Tesla has become one of the most respected and feared names in the industry. The automotive world is filled with companies that once promised to revolutionize transportation, but failed once mass production began. Designing a single advanced electric car is already difficult. Producing millions of them consistently at affordable prices while still remaining profitable is an entirely different challenge. Tesla recognized this reality earlier than many competitors. While other companies focused heavily on marketing and flashy designs, Tesla spent years solving manufacturing problems behind the scenes. Those difficult years are now giving Tesla a major advantage that the rest of the industry can no longer ignore. Recently, Tesla revealed that its next-generation drive units are being designed not only for speed, efficiency, and performance, but also for manufacturability. a factor that could dramatically reshape the future of electric vehicles. Tesla's goal is ambitious. The company wants complete drive systems, including motors, electronics, and gearboxes, to cost roughly $1,000 to manufacture. That figure sent shockwaves through the automotive industry because many competing systems cost several times more. Some manufacturers reportedly spend 3 to 5 times that amount to achieve similar performance. The difference is enormous. What makes Tesla even more competitive is its ability to reduce costs while continuing to improve performance. The company is also working to eliminate rare earth materials from its motors, reducing dependence on expensive supply chains that are heavily tied to China. At the same time, Tesla has been redesigning its electronics to reduce the use of expensive silicon carbide materials while still maintaining high efficiency. Each improvement strengthens the company's overall advantage. Lower manufacturing costs allow Tesla to reduce vehicle prices. Lower prices attract more customers. More customers increase production volume, and higher production volume gives Tesla even greater manufacturing experience and efficiency. That added experience helps the company lower costs even further, creating a cycle that continues growing stronger over time. Meanwhile, many competitors are struggling to keep pace. Ford introduced impressive electric vehicles, such as the Mustang Mach-E and the F-150 Lightning, but reports suggest the company has lost significant amounts of money within its EV division. Lucid Motors developed luxury electric vehicles with advanced technology, yet the company has continued spending cash at a very high rate. Rivian gained massive attention and investment, but its production costs have remained extremely high. Even major automotive giants like General Motors and Volkswagen have faced delays, software challenges, and increasing concerns about profitability in the EV market. Among Tesla's global competitors, BYD appears to be one of the few companies capable of challenging Tesla at large scale, especially in more affordable vehicle segments. However, BYD's biggest strength mainly comes from cost competitiveness. Tesla, on the other hand, is pursuing something much larger. The company is not simply trying to build inexpensive electric cars. Tesla's goal is to create some of the world's most advanced and desirable electric vehicles while also making them affordable to manufacture. That combination is what makes Tesla so powerful and why many consumers increasingly see the company as a leader shaping the future of transportation. But Tesla's ambitions extend far beyond cars alone. Many people still view Tesla as primarily an automotive company, but that may be one of the biggest misconceptions about the business. Tesla's real strength comes from how it connects multiple industries into one powerful ecosystem that continuously reinforces itself. It begins with data. Every Tesla vehicle on the road constantly collects driving information. Every mile driven helps the company learn more about road conditions, traffic situations, weather patterns, driver behavior, and unusual events. This matters because autonomous driving systems improve through real-world experience. Tesla has accumulated more real driving data than almost any competitor, and that advantage keeps growing over time. More vehicles generate more data. More data improves Tesla's AI systems. Better AI attracts more customers, which then creates even more data. It becomes a self-reinforcing cycle that competitors cannot easily replicate overnight. Then there is Tesla's battery business. Tesla invested billions of dollars into battery production because batteries remain the most expensive component in electric vehicles. The company's 4680 battery cells are designed to improve energy density, reduce manufacturing costs, simplify production, and increase overall performance. While many competitors still rely heavily on outside suppliers, Tesla is working to control more of its own supply chain and technological future. The company also designs much of its own software, computer chips, power electronics, and vehicle systems internally. When global semiconductor shortages disrupted the automotive industry, Tesla adapted faster than many rivals by rewriting software to support alternative chips. That flexibility revealed an important reality. Tesla often operates more like a technology company than a traditional automaker. Its rapid manufacturing expansion reflects the same strategy. Tesla factories in Fremont, Shanghai, Berlin, and Austin now form a growing global production network. Future factories planned for regions like Mexico and potentially India could help lower production costs even further while opening access to enormous new markets. And then, there is one of Tesla's most underestimated advantages: the supercharger network. For years, critics viewed Tesla's charging stations as simply a convenience feature. In reality, they became one of Tesla's strongest competitive advantages because the network is fast, reliable, widely available, and easy to use. Many competing charging networks have struggled with broken equipment, confusing payment systems, compatibility problems, and inconsistent reliability. Eventually, several rival automakers effectively accepted Tesla's dominance in charging infrastructure. Companies like Ford and General Motors adopted Tesla's charging standard so their customers could gain access to Tesla's supercharger network. That shift is remarkable when you think about it. Tesla's competitors now depend on Tesla's infrastructure to improve their own customer experience, and Tesla benefits financially whenever rival EVs use its charging stations. This goes far beyond normal competition. It represents ecosystem-level dominance. So where does Tesla go from here? Can the company continue leading the market, or will growing competition eventually slow it down? To understand that, it's important to look at how Tesla is evolving beyond traditional automobiles. The more closely people examine Tesla, the harder it becomes to describe it as simply a car company. On the surface, Tesla manufactures electric vehicles, but underneath, it is transforming into something much larger. A technology company built around energy, software, artificial intelligence, and data. One of the clearest examples of this transformation is Tesla's Dojo supercomputer. Dojo was specifically designed to train Tesla's artificial intelligence systems using enormous amounts of driving footage collected from Tesla vehicles around the world. Instead of relying entirely on traditional computing infrastructure, Tesla created a system optimized to process driving data faster and more efficiently. This is important because modern AI systems improve by learning from massive amounts of real-world information. Most companies in the industry still depend heavily on outside computing providers, often renting cloud services powered by companies like NVIDIA, Amazon, Google, or Microsoft. Tesla chose a different strategy. Rather than depending completely on external platforms, the company is building much of its own computing infrastructure internally. The reason is straightforward. Tesla believes its future success will depend not only on the vehicles it sells today, but on how intelligent those vehicles become in the future. This creates another powerful self-reinforcing cycle. Better technology attracts more customers. More vehicles on the road generate more driving data. More data allows Tesla's AI systems to improve faster. Smarter AI strengthens self-driving capabilities. Improved autonomy increases the value of Tesla vehicles, leading to higher profits. Those profits can then be reinvested into further research, software development, and advanced hardware. Over time, the cycle continues becoming stronger. Because of this structure, many analysts believe the competition in the EV industry is no longer only about building cars. Tesla is competing across multiple areas simultaneously. Battery technology, software integration, manufacturing efficiency, artificial intelligence, real-world driving data, charging infrastructure, and large-scale global production. For competitors, catching up in even one of these categories could take years. Matching Tesla across all of them at the same time is an even greater challenge. Even Tesla's hardware breakthroughs, such as advanced motor designs and innovative materials, are part of a larger pattern. The company continues solving engineering and manufacturing problems that many once considered too difficult, too expensive, or simply impossible to overcome. The electric vehicle revolution is clearly happening, but it may not unfold the way many originally expected. Instead of a balanced market filled with equal competitors, the future may be shaped by one company moving faster, learning more quickly, and building a deeply connected ecosystem that others are still struggling to fully understand. So what do you think about Tesla's breakthrough motor technology and its growing influence on the EV industry? Do you believe Tesla can maintain its dominance for years to come? Share your thoughts in the comments below, and don't forget to like and subscribe.